I'll talk to you a little bit about the origin of why this webinar came to be. So the three names you see there, Martin Richards, Carsten Schultz, and myself, Nathan Allison, we three were involved in a development of professional learning and lessons related to AI for the Digital Technologies Hub. And we did this work over the last 2 years, 2020 and 2021, with the professional learning webinars all being done last year in 2021. And we're really excited about it because this is a moment in time when there's a lot of tools and lessons and ideas and practical hands-on ways that you can do AI stuff with students. And a lot of these tools and lessons really do tie quite directly into the digital technologies curriculum, as Martin will be explaining shortly. So that's sort of the origin of this webinar. We're just going to go through some of the things that we did do in those 2 years and point you to a lot of things that have been made, and hopefully it will inspire you to be able to talk about AI and do some work around AI if you're teaching digital technologies or even if you're teaching other subjects in your schools. I might just get Martin to introduce himself. If you want, Martin, go for it.
Hi everyone. My name is Martin Richards and I'm the content manager from the Digital Technologies Hub. So what that involves is just putting together all the content for the hub, and I've worked on the hub for 5 years. And if you go there now, if you've had a bit of a look around, you'll see it's had a bit of a refresh and it looks a whole lot more improved layout and functionality. So have a bit of a look at that. Yeah. So Carsten.
Hey, thank you, and good day. My name is Carsten Schultz. I'm heading up the Digital Technologies Institute, where we have educational resources like our B4 CPU and the My Computer Brain AI. I'm going to show you some of that today when we do some experiments together. I came to AI originally just as I was leaving high school, and my computer science teacher at the time, he gave me a paper about a new thing at the time, said, artificial intelligence, have a go, okay? And that set me on a path. So it was one of your colleagues who is partially responsible for some of the things that you're going to see today. So you can thank him then for that. And so I'm very excited to be with you here today.
Thank you to you both. And I'm Nathan. I'm Professional Learning Coordinator here at DLTV. We're the Subject Association for Digital Technologies in Victoria. And yeah, I was brought in on this project last year and helped to develop some of the resources as well as the professional learning for the secondaries. So you can see on this slide, there's a link to the PDF there, a little bit.ly link to take you to the PDF for today's slides. You'll have noted that we are recording this webinar. The recording should be available within 10 days from today, and it'll go up on DLTV's YouTube channel. And if you have registered for this event, you'll get a follow-up with the link once that's published. Because we are recording, we do ask everyone to keep your microphones muted. And if you don't want to possibly be seen in the recording, you'll probably want to also keep your video turned off. Before we begin, I'm going to put a link in the chat to a little whiteboard. And this is just sort of to get you thinking a little bit. What does AI mean to your students? And let me paste this. It's one of those jam boards. I'm just pasting that link now in the chat. You'll see a link there. And it's a whiteboard where you can basically put anything you want on there. You can put text, you can draw things, you can put in an image, or you can find an image on the internet, stick it in there. But the idea here is if you were to Netflix, yeah. I love you taking the time to draw that on. Thank you. Yeah, Netflix, the way we perhaps, recommendation algorithms from, video sites, how does it know what it thinks you're going to like to watch? Yeah, cameras watching people, facial recognition perhaps with those cameras. The cameras themselves are not necessarily AI, but the software that does the facial recognition and tries to tell who you are, that could be considered AI. All right. Great. If there's any more, feel free to continue putting in there. We can keep that open. And I'll just switch back to our slides now. And I'm going to hand over to Martin. Here's what we're planning to do. Martin's going to talk about the background of the project and then why AI in the classroom and how it connects with the curriculum. Carsten's then going to show us some of his cool visualizations of AI, and he's going to do a primary levels example of the way data can be explored and data representation when you're talking about machine learning. I'm going to do more of a secondary example showing how AI can be brought in and used within a conventional program, and it'll be a JavaScript program in this case. And then at the end, Martin will come back and talk about AI and how it ties in with ethics as well. And we'll finish with some time for questions. All right, take it away, Martin.
All right, thanks. I think I'll start by just talking a bit about the project. And where we really started was after an initial bit of research in thinking about all the topics that come to mind when we're talking about artificial intelligence. We developed a scope for these lesson plans, and there's nearly 30 lesson plans on the digital technology site. So a lot of the initial work that we did was researching the types of things that students could do. So the tools, what tools were around, and we'll talk about some of those tools. But that brings to life the artificial intelligence that we could sort of talk to with our students, and also provide them with some key tools to experience what it actually is and build their own models of that, which we'll talk about today. So once we had all these lessons up and running, we realized that we needed the professional learning to back teachers and support them to say, well, here's these lessons and here's what you can do with it. So we went about designing 10 professional learning sessions. So we divide up into primary and secondary. So on the next slide, you'll be able to see the link to the resources that we have. So when you visit the site, the digital technology site, you can see, okay, I'm a primary teacher or I'm a secondary teacher. And for each one of those sections, for those modules, so each one has an introduction to AI, because we thought it was really important just to give you a broad brush. What is AI and how does it relate to my students? Both of them really focus on the fact that we're trying to develop in students an understanding what it is, but using their own language to explain it. And like Nathan just did before with the Jamboard, starting where the students are and then working towards building their knowledge. And the same was with our professional learning, starting with an introduction to the class, AI in the classroom, but then moving into sort of more deep dives. If you're interested in looking at the programming connection, what's the connection there with AI and looking at algorithms, or you're going to go down that pathway of the data representation, which is really interesting. Machine learning is something you probably hear bandied about, and your concept of that, depending on whether you've had much to do with AI, maybe could deal with some different sorts of information. So when you're sort of looking on the internet, there's quite a few complex sort of definitions of machine learning, and for students it might be hard to work out. Now we produce some videos to go along with that. So machine learning, what is it? We've got some video explainers, and we'll talk about that towards the end if I can show some of them. Links to those the videos, what we've done, those 4 videos as well. So there's a host of resources for each one of those modules, the recorded webinar, the outline with resource links and presentation slides. So you could go through and self-paste and pick out the bits you want. You might just want to do 10 minutes of a session and just see how to do some programming. You might want to focus on the data representation, but we've got enough there for primary and secondary teachers to go through. And I'd recommend to have a bit of a look at that, those resources. Maybe Nathan on the next page. So it is really interesting. Why are we doing AI in the classroom and what concepts? And when we're trying to focus on not just learning about AI, but we're trying to look at how it underpins, or it's underpinned with the digital technologies curriculum. Essentially, it's important you're teaching these concepts about digital technologies. So what we're using here is AI topics to give you that context, to give you that authentic, meaningful context that you could talk with your students about an emerging technology. So you can see here when the next topics, the AI topics that we worked on, just give us the next slide, Nathan, if you can. Yep. So these are sort of topics we thought these are really going to generate some really good thinking for students and image recognition, teaching text and speech recognition, creating and using AI models that's going to incorporate machine learning, and then this notion about bias and ethical issues. So you might have heard about bias in AI and whether or not that has some negative consequences at some points, but also this knowledge about ethical issues. So when we're talking about, say, digital systems and then data representation, AI needs, it really relies on a whole range of data. And if you can just give us that next click there, Nathan. So we've got this notion here, we've got sound, images, text and sensory data. So we can really talk about in a digital system, how is this data used and what's the input, what's the output? So it's a really good way to talk about something that's quite complex, but it'll start to really make sense with students. So when they're looking at how, say, an AI can see, how does it know the difference between a crocodile and a stump? How does it know the difference between a car and a traffic light? You can look at the sort of data and the images that it brings together. So there's a really good combination there. When we're looking at defining and decomposing problems, we're really looking in there at computational thinking. So we've got a really good reason to unpack a problem if we're looking at a system and how it works. And we've got some of those examples in the lesson plans. So abstraction is probably something you thought, oh, what is abstraction? And that's really just focusing on the things that are important. And we're not focused on all the information. We're trying to pick out the bits of information that's really important in that. So in terms of decomposing the problem, we're looking at some algorithms. But in the case of AI, maybe some of the times if we're using machine learning, we're not actually using algorithms. We're not doing any coding, but we are still using that as part of our one of the tools to create a solution. And then we're looking at the impact of technologies. For example, imagine a driverless car. What is the impact of if we have that in our society, and what happens when things go wrong and who's responsible? And I'll talk a bit about that when we talk about ethics. And then we've got this notion about that bias I mentioned. So if we've got people are designing AI systems, and if they've got an unconscious bias, maybe might be towards gender, it could be towards diversity of people. All these things can be affecting how the AI system works, and we can get into those sort of things. So it's a really rich area, and again, we're just going through broadly about what some of the connections are with the curriculum, but this notion about systems thinking, design thinking, computational thinking, it really gives us a great way, an intro into these areas and to give it purpose to learn about these things. So I recommend if you have a look at some of the lesson plans, you'll see all this come to life. That's me done.
Okay, thank you, Martin. So I'm going to follow up from what Martin said and talk about it from the perspective of data. And data is a wonderful topic, and in the context of machine learning and AI. And there's one thing that I really want you to take away from this presentation, from this part of the presentation at least, is that AI and data is really a love story. Okay, they really like each other. And AI is a wonderful field that if you want to explore data a bit more, and keep in mind that in the current version of the curriculum, data makes up 3 of the 10 key concepts, then I highly recommend to explore that in the context of AI. So let's take a look a little bit about what we mean when we say data in the context of AI. So here's a little activity. It's called Auto Draw, and it's a wonderful entry-level activity with your students, certainly at primary level, where you simply draw something. Yes, here with our mouse, we are drawing a shape which resembles an apple. And if you look at the top of the screen, that's how the AI is working in the background. And it's trying to make sense out of that shape as we draw it and tries to identify what does that thing represent, okay? And as we draw it, the AI gets more and more information and gets a better prediction until at the end it predicts, yes, it is most likely an apple, and then we can click on that and it then will give us the shape. So the question is now, how does the AI see that information that we are inputting into the system? And we can look at it from different perspectives. Next slide, please, Nathan. And it fits really well with the different year levels in the Australian curriculum when we talk about data representation. Just to recap, data representation is how data is represented and structured symbolically for storage and communication. And I should say for people and digital systems, and that has both aspects in it. So when we're looking at it from an F22 level, then we are having data represented as simple pictures and symbols. You see that here on the left. That is already enough information for an AI to do some meaningful work. And then as we go higher in the year levels, in years 3 to 4, we're looking at a more refined representation of the information, in this case a smiley, and we're looking at it, maybe you can represent it in different kinds of images that have got different shapes and colors, whether it's on a microbit or perhaps just a checkbox that we select or deselect. But then in years 5 and 6, when we go into the area of representing data with whole numbers, and then in year 7 and 8 with binary, then it becomes really interesting. And this is the point where we can then dive a bit deeper into the artificial intelligence to understand how it deals with data. And that's what I would like to do with you over the next couple of minutes. Nathan? Yeah. So here you see a pixel representation, pixel graphics, and that's what we're going to use. Okay, next slide. So the key question that we're trying to address here is, how does an AI represent data? And in order to answer that question, we need to look a little bit deeper. We have to distinguish between the input of the AI and the output. Now, the input of an AI for our purpose here today is it's generally binary input data. Very simple, zeros and ones, we know that. At the output side, we usually get floating point values, but they're also usually in the range between 0 and 1. And we also call them confidence value. We're going to see them shortly. And when you round these confidence values to the nearest 1 or 0, then we get what we call a classifier. This one, the AI tells us it's an apple. Okay. Good, let's look at that a bit more detail. So let's look at it from the input side first. So we start with the black and white matrix. Here you see the image of an emoji. We have got a 7x5 matrix here. Could be at any different size. We just use this as an example. Okay, and each pixel represents a bit, a 0 and a 1. So far, so good. So now we need to decide what represents what. If we go to the next slide, please, Nathan. Then we decide here that a white pixel is represented by a 0 and a black pixel by a 1. Now you might say, why not the other way around? Because when you look at it from a screen perspective, you would say, well, a black pixel is usually switched off, isn't it? So it's 0 and a white pixel is switched on, so it's a 1. Now that comes back to my teacher, because that was the way it was done in that paper that he handed to me many, many years ago. And it makes sense because it was done on a paper base at the time, and the paper is usually white. In that case, there is no additional information, so that's why it's 0. And any black pixel we put on it was 1. It doesn't matter which representation you choose, white 1 or black 1, and the other color 0, as long as you stick with it. Okay, so in this case, just for convenience, we're going with white is 0 and black is 1. Okay, so by representing these pixels with 0s and 1, we are getting a binary number. And we can look at how the AI sees that on the next slide. And this is a screenshot from one of my AIs. And you can see here that in the animation that we have this 7x5 matrix, and simply 1 pixel maps to 1 input of the artificial intelligence. Now, it's actually not too dissimilar with our eye, where we've got the retina and the optic nerve, and that goes into our brain. Okay, so you can use that as an analogy. Okay, so every single pixel maps to 1 input in the artificial intelligence. So our little smiley face here with its 35-bit is going to map to 35 input neurons in the artificial intelligence. Okay. Let's take another look what that means here. So we go with binary, and I should say that AI is one of the few applications, I think, where binary makes absolutely sense. It's actually much better than a decimal representation, going to look at that now. If you can go to the next slide, please. So our binary number, if we want to convert this into a decimal number, then we've got this monster here, which is like 336,115,712. Wonderful number. What does this tell us? Absolutely nothing. Okay. Whereas if we stick with the binary representation here, we can actually see the image much better. Okay, so we decide we stick with the binary. Okay, we don't go to decimal. Usually students try to convert between binary and decimal all the time because decimal is what they're used to. Here, they probably want to stay with the binary representation because it helps them. Okay, then with this approach, we can, of course, represent any kind of black and white picture as binary numbers. So whether it's a happy, a sad, a surprise, or an angry emoji, doesn't matter from the AI's perspective. That's all just binary data. Okay, next slide, please. So let's do a little activity here. We've got this emoji here. That's our surprised emoji. And I would like your help in order to convert this picture to a binary representation with white being 0 and black being 1. Can you please tell me what the next row is? So the second row, the first row is 5 zeros. And can you please type into chat what you think is the binary representation of the second row, please? Okay, I can't see the chat at the moment, but Sandy, yep, 01010. Yep, Carolyn, wonderful, great. That is correct. And Nathan can show this now in the slide. Okay, let's go to the third row. Third row looks like the first row, so that's an easy one, which means we're having 5 zeros again. After that, the fourth row. Who would like to take make an attempt at solving the first row, please? 0, 1, 1, 1, 0. Well done. Congratulations, that's correct. Then the fifth row, please. 1, 0, 0, 0, 1. Yep, that's correct. Thanks. Well done. Yep, everyone got it right. And then the sixth row. That's like the fourth row, isn't it? So it's 0, 1, 1, 1, 0. And the last row is again 5 zeros. So there we got our binary representation of our little pixel image, and that's what we can feed into the AI. So let's take another look at that. Okay, so this approach is not limited to pixel graphics. We can also represent all kind of information, for example, words. So let's explore this in the context of a home automation scenario. We talk, say, hey Siri, do this and that for me. So how could that look like? Here's a model. So each word, and I just said, hey Siri, and Siri responded to me. Okay, well done. So this is how we could do it in an AI. We define words that the AI should recognize, like switch, lights on, off, too dark, bright, fan, warm, cold, and then all kind of combinations, and would simply assign a binary value. So we've got 10 inputs here, and if we want switch, then we simply say it's a 1 followed by 9 zeros. Okay. Very simple, works. So switch, lights on. If we want to then do a combination of these 3 words, that would mean three ones followed by zeros. Okay, good. Just as a warning, you don't want to convert the individual letters of the word into Unicode. Here's an example. Again, it's like a decimal representation in the pixel graphics before. It is correct, but it doesn't really help us much. Okay, it's quite complex. Certainly for professional AIs, we would do that, but for a school environment, we don't have to. Okay, so we stay away from that. Okay, so ultimately, that's everything's equal from a binary perspective. It's just ones and zeros, and the AI really does not care about whether we give it a pixel or a word for it. As long as we give it binary input data, it is quite happy and can work with that. Next slide, please. Okay, so what happens on the output side? On the output, the AI usually gives us information like in what bucket something fits. And here you have a screenshot by Google Teachable Machine. And here the AI tells us that it believes that this little emoji here represents a sad face. And that's so far correct. And the AI is very certain. It says, I'm 100% certain that this is a sad image. So far, so good. Good, what happens next? We can give it a different image, and here Martin has actually drawn one on the back of another emoji. And here our AI says, well, I think it's pretty much sad. I mean, over 70% sad, but there's an element of happiness in there. So it says 70% happy. And if you look very closely, you can see shining through the happy emoji that's printed on the back of the page. So the AI sees that too. And then the AI says, well, there's also an element of background in it. And that's correct, because we also see the background, because the emoji is not filling the entire screen. So the AI is not just giving us binary decisions saying it's sad, but it says, well, it's mostly sad, but also a bit happy, and has a background. And really, that is really just the way that we are doing it as well. When we see things, we're saying, oh, look, it's got an element of this and that, and then we make a decision what we want to do with the information. And so does the AI do that too. Okay, let's look at the next slide. You may be interested to hear that AIs can also have confidence issues like humans. Okay, after all, AIs are based on human learning as well. So this AI believes that it is seeing a happy face. Okay, pretty certain. It's very confident that it has a happy face, 93%, but really it's a sad face. And there's just this little voice in the background that says it's sad, this thing, but the AI doesn't quite believe that. And the reason for that is that our little AI model has an issue. In this particular case, it has got a size issue. Would you believe it? Because Martin trained the AI at the time just with images of large emojis like these here, and not with small ones. So the AI took a certain impression that an emoji always has to be big in order to be sad, and otherwise it's happy. Interesting thing. And this then plays into biases, which we solve by providing the AI with additional data. But I want to show you one more thing as a lead up to Nathan's part, which is coming next, and that is our thumbs upper. And we are doing, Nathan is going to do a very nice coding activity in order to distinguish thumbs up and thumbs down with an AI. And we just want to show you what that would mean in the background. So the image is again being represented as ones and zeros in the AI. In this case, you see an image of a thumbs up, so fist, thumbs up. Okay, that's what you see here in the image, and the corresponding binary representation. Okay, so again, binary data is flowing into the AI. And the way we do this, then, you see this on the next slide, is that we're going to train the AI with various images of thumbs up. And here you see a few options of how the image could look like that we're feeding the AI with, so that the AI gets an impression of what a thumbs up mean. It looks at it from different perspectives, different sizes, different orientations, and so on. And Nathan is going to show that shortly. So I just want to go quickly into the environment and then hand it back to Nathan. And I'm just sharing my screen here, and then you can see the AI in the background. Just a moment.
So because we've got a bit of limited time today, Carsten will be showing you one of the visualizations that is used in some of the lessons and quite a bit of the professional learning that we did. In this case, you can see what looks like a sort of a representation of a neural net. And although there's limited time to talk about neural nets today, it is something that you can find a lot more about if you go into the Digitech Hub and have a look at the professional learning webinars.
Is my screen actually sharing, Nathan? Because I don't see a preview on my end. It is. Okay. I put the link into the chat, and then you can explore that after the workshop. And with that, I hand back to Nathan.
Okay. I wanted to do an example from secondary, and this is one that's in, it is in one of the secondary deep dive webinars as well. So I won't be going quite through as slowly and deliberately as I do in there. But what I wanted to do is to make a little one-question quiz. And if you can imagine a program, just a very simple program where it asks a question, it's a yes or no question, the user answers by pressing yes or no on the keyboard. That's a very simple program for students to make. But then if we were to upgrade that so that instead of the user pressing yes or no on the keyboard, they can actually put their hand in front of their webcam and show a thumbs up or a thumbs down in order to provide their answer. And the program would respond as if they'd done Y or N from the keyboard. So in this example, we're going to design and code the conventional program, the algorithm, and then we're going to prepare an AI model that recognizes those thumb gestures. And we're going to use, to do the conventional program, we're going to use an online JavaScript environment called P5. We choose this one because it works pretty well with models that you get out of Teachable Machine, and it works nicely with webcams and things. But there are potentially ways to do this with Python as well, and I'll also provide some examples of Python-related lesson ideas as well later on. But yeah, so we'll prepare the AI model, and we'll use Google Teachable Machine for that. And then we will bring that model in and adjust the program so that it actually uses that model to work with the quiz. Now, in terms of the conventional program, here's some of the parts of the algorithm. This is just a flowchart, but here's some of the parts of the algorithm that would be needed to make this program work. And I'll put those into their right places. We're going to ask a quiz question. We're going to wait for the user to press a key, and then we're going to keep checking, did the user press Y? If they did, then we set a variable called answer to yes. If they pressed N, we set that variable to no, and then we display a result. Did they get it right or not? We give them their result. Did they get the answer right? Now, as I said, the conventional program, I'm doing it in this P5 environment. And if you have the PDF of these slides, you'll be able to access these links and see the programs. But I'll just very quickly switch over to the conventional program so that you can see what it looks like. So let me switch here now. It's actually, the program is very small at this point. You can see the only thing that's been introduced is creating a capture of the video. And all that does is show that on the screen. So if I turn my webcam off here, and then I'll turn it on here. There you go. That's all the program does. It shows me. It doesn't respond. It doesn't do anything at this point because there's no code set up to answer the quiz or do anything. Okay. So I'll stop that program. Now, if we go on to the next stage of the program, though, we've introduced a variable called answer. And what we've basically done is we've added a bit of code to that draw algorithm. It's going to put some text on the screen to say, is Earth the closest planet to the sun? Then it's going to wait for us to respond. If the answer is yes, it'll say, that's incorrect. Mercury is the closest planet to the sun. If the answer is no, then it will say correct. Now, how is it getting this answer? Well, that actually comes in this separate function here that responds if they type a key. So this is what, like a triggered function that comes up if the key is pressed on the keyboard, and it sets the answer to yes if they press Y, and it sets the answer to no if they press no, so that this can keep responding correctly. Now, if I run this one, you can still see my face, but it's not responding to my hand gestures yet, but it is responding to my keyboard. So if I press Y on the keyboard, I have to click in here first. It says incorrect. Mercury is the closest planet to the sun. If I press N, it says correct. Y again, incorrect. So that program is working as it should by just responding to my key presses. All right. So we've got a working program so far. Let's return to our slides. The next step, of course, is that we have to think about the data that we're going to give to this. If it's going to respond to thumbs up and thumbs down, we need to decide, well, how can we represent Y and N clearly? And we don't have to use thumbs up and thumbs down. We might consider, oh, what's another visual way of representing that? Maybe it could be sign language, or maybe a different gesture that means yes or no. And these are interesting questions, and sign language is actually a bit trickier than you would think because it's an animated thing. The hands are moving with sign language. They're not just stuck in one position. So it's actually a bit more challenging to recognize sign language. But I'm going to do the thumbs up and thumbs down. We're going to need multiple photos. Carsten was explaining that unless you have quite a bit of data, it can be unreliable and biased. So we're going to collect multiple photos with different angles and directions of my hand. And we also have to consider the background. Is it going to be blue all the time? You know, I happen to be in front of a nice blue screen, but is it going to be blue all the time? So to prepare this model, we're going to use Google Teachable Machine. And there was a couple of screenshots of it before. I'm not going to take you through the whole process, but I will give you a quick demo of what Google Teachable Machine does. So if I quickly show you, this is the website. We get started, and we're going to do an image project, standard image. And basically, it uses my webcam, and I just put my two classifications here. So this could be thumbs up, and this could be thumbs down, and you could add other buckets as well. And I'm going to use the webcam, and I'll switch to the one that I've been using here. There it is. So you can see me there. It's not recording any images yet, but if I get myself out of the way and then put my thumb there, this is my thumb for thumbs up, and I can hold, and it will record a few different images of my thumb doing a thumbs up there. And I've got a few samples of that. And then I can do the same thing with thumbs down. So once again, webcam, and this time I'm doing thumbs down. It's a little bit blurry with my webcam there, but there's my thumb pointing down. Now you'll notice I've only done my thumb in one direction, so that's probably going to cause some issues later. But you get the idea of the two sets of images there, and then we can hit a button to train the model. And this might take a little while, depending on how many images there are. Just while that's happening, one of the things that Martin may mention towards the end, but we spent a bit of time during the webinars talking about the importance of data and privacy with students, and the fact that when you're using a webcam, you are potentially showing your face, showing your image, and that data is traveling onto other servers in the world and so on. So there are steps that students can take and that you can take as a teacher to minimize those issues or to avoid those issues with the kind of data that you choose to use. So this is the little testing environment now. So this is Teachable Machine testing to see if it's doing a good job at recognizing things. So thumbs up, thumbs down, that's pretty good. What if I go like that? It's not so sure, but it's pretty good with the thumbs up and thumbs down, so it's not too bad. The last thing that we do, of course, is we export the model. And again, I won't take you through this whole process, but if you upload the model, which is basically the information that allows these choices, these predictions to be made, what we get is a special URL that we can use whenever we want to use that model. And that's basically the whole process of training it. And we, as I said, we'll get a URL. It might take a little while, so I'll skip back to the slides. Oh, there you go. So that's my unique URL that I can use in a program if I want to use this model from Teachable Machine. Okay, so let me switch back. So we've now trained our AI. We pressed the train button, we did the model, we tested it out, and we exported it. We got that special URL that's unique to our model. So that's all done. And the last thing now is to bring that model into the program so that we can use the camera instead of the keyboard Y and N. So the last part here, again, there's links there that will take you to the final two programs. But I'm just going to skip straight to the last program here and show you the code. So here's the final program. I've noted down that URL. It's slightly different because it's one I prepared earlier, but here's that URL for the model. And I've used it in my program here to make something called an image classifier. And I can just use that URL that came out of Teachable Machine in there for the classifier. And then there's just a few extra bits of code that have been added. We begin classifying, and we set up an extra function down the bottom called got_results. It's not that different to the one that interrupted for the keyboard, but this time it interrupts if it sees a correct result, like a thumbs up or a thumbs down, and it sets that variable. If it sees thumbs up, it sets that variable. If it sees thumbs down, it sets that variable, and it makes sure that it keeps checking the camera. And all the other code stays the same, because remember, the main code is just looking to see for yes or no. So if we test this one out, this will be the final test. So I'll get out of the way again. And if I put thumbs up, it says incorrect. Mercury is the closest planet to the sun. If I put my thumb down, it says correct. Earth is not the closest planet to the sun. So that means my program is pretty much working and responding. Now, of course, that's a very simple quiz, but you can sort of imagine more advanced things that your students might be able to do by using that trained model in their conventional programs. So there we go. That's that little demonstration. I'll just switch us back to the slides. We're almost at the end now. Very quickly, a couple of other secondary lesson ideas. The rock, paper, scissors lesson there, that one is very similar to what I just demonstrated. And then there's another one that's also JavaScript using the pencil code environment, which does a bit of general purpose programming. And then lastly, there's a couple of Python ones here for those of you who work with Python. So you've got sentiment analysis lessons that we developed with Sandy Dedic, where you can code a chatbot and it can tell if your answers seem like they're positive and negative. And you can analyze large texts and see if you can identify the heroes and villains. And then finally, one of the things we did, Carsten and I did in one of the webinars, was to actually use some Python code to test a real neural net on some real data. And it's really fascinating, but AI can help you to find a line of best fit. It can help you to perform a linear regression. So if your students are doing that in maybe VCE maths, that's something you can actually do with AI as well. So it's just a fascinating thing. So please do feel free to check out those links. And if you have any other questions about anything we're talking about, of course, you could put them in the chat as Martin does his section now. Thanks, Martin.
Okay, that's excellent. Just reminded me when you were doing those, you did really well too, doing those examples with the coding, and we made the point about remixing code, and a lot of our lessons have sample code, and you might think as a teacher, oh well, I'm just going to get the kids to copy someone else's code. That's not really good. So there's a real pedagogy behind remixing and using another code from someone else. So you can imagine in that sort of environment that Nathan just showed you, the fact that a student who may not be so good at coding could use that as a scaffold and could change just the coding of the question and adding a different question, but then realizing how that code could be used and then putting in their own model. So it allows for really a powerful way of learning, and I just think that we referred to the prim pedagogies, and again we went through that in detail in the actual lessons and with the professional learning, but I thought it's a worthwhile point just to make. AI and ethics, yes, this is another area where it's sometimes teachers would have real difficulty in trying to think of ways to do this. If you're looking at ethical understanding and the general capabilities, how do you teach this? And AI brings a really good context to look at ethical issues. Just as a reminder, how do we deal with ethical issues in the classroom? And this is where we've got examples of situations where there's competing alternatives. So it's not really clear what the right thing to do is or obvious, and we have different perspectives. So everyone brings their own perspective and their own moral compass, or however you want to describe it, about how they might refer to a situation and what they might do in particular times. But we often talk about the effect in this ethical sort of space about, well, that's going to be good for the environment or bad for the environment, or this is good for those people but bad for this group of people. So we're always looking at how these ethical sort of issues play out in different sorts of scenarios, and who's affected and who's who might win and who might lose, you might think. So in the next slide, Nathan, we've we looked at ethical dilemmas and we thought, well, what ethical dilemmas can we use from the AI perspective to look at that? And we use this particular framework where we, first of all, we're saying, okay, let's explore an issue that we could sort of get a sense of what's actually happening. What is the problem? What's the issue? So just getting students to understand what is the issue here, that's a pretty big step. And some students might not be quite clear about, well, what's the issue? I don't see what the problem is. Or that discussion it takes quite a bit of time. Then we select and justify an ethical position. So we might have 3 or 4 options and we say, well, this could happen or this could happen. And what do you think? Which option would you take? But not only what would you take, but why? Why have you chosen that particular option? And that's really important to talk through and to get that group discussion. So a lot of this work would be presenting some sort of scenario and having this class discussion. So you will have to bring in students, and it would take some really good classroom management just to make sure that everyone gets a chance to say their thing, and you would have those rules in place. And then also reflecting on and interrogating the sort of what are the core ethical issues. So I thought it'd be good just to try one of our quizzes. So Nathan, our first quiz that we're going to go through is, this is, if you want to go to the lesson, it's called AI Quiz. So yeah, that's a good title, isn't it? Sort of explains what it is. But in this one here, we've got the focus is on facial recognition. So we're trying to bring in this AI concept, facial recognition. And this company is designing an AI application. It uses facial recognition so to unlock the smartphone, all good. But through testing, the company found out the AI only worked most of people, but not all. Okay, so they went back to the drawing board. What did they do? Let's have a look in the next situation. So A, B, C, or D. So A is, hey, let's sell the phone. Using the AI, we'll make the money and then we'll make the fix, and then we won't, in the next version, we'll just fix the issue and we won't mention there's any issues. So that's A. B is, we'll take longer, we'll spend more time, we'll use more money, we'll train the AI so it works for all people. C, we'll sell the phone using this AI, but we'll also have a little warning that says it may not work on everyone. Or D, we'll fix the AI, but because it's taken us so long and it's made us a little bit behind time, we're going to charge a higher price so we can still make the same profit. So Nathan's got a poll, I think, there. You can have a bit of a go at it. A, B, C, or D. We're probably going to have a small group of input, but you can see there how basically you could use that in a group, and you can ask why you would choose A, or why you would choose B, C, or D. So Nathan, I don't know if we're going to get any poll. You can tell me what's happening.
No worries. Yeah, if you're not sure where the poll is, it should be there on the right-hand side where the chat is. I think it'll appear in the chat. So if you still haven't had a go, have a try there.
Oh, yeah.
Oh, yeah, we've got 1 or 2 votes coming in now.
You have to, yeah, vote. Yep, got it. Yep.
2 votes for B at the moment.
Yep. So I'll let you have a bit of a go with that. But essentially, while you're thinking about what your choice would be, if we interrogated this more, what's behind this issue? What is the issue? So that's what I'd be asking the students to say. What's the issue behind this whole AI situation? Why is it an issue? And you might say, well, there's people out there who are going to get the phone who are not included. So that whole thing about inclusivity is part of an AI model in terms of making sure it works for everyone. And that's really important. So being inclusive is really the whole catch cry behind this scenario. And that's what you'd sort of talk through, and you'd probably talk through and say, you can use that empathy and say, well, how would you feel if you picked up the phone and yours worked, but the person next to you, how are they going to feel if it doesn't work? So you're trying to put them in the person's shoes who's being affected, and then talk through that process. Let's go to the next one, Nathan. So self-driving cars, again, when you bring these ones up and there might be some issues where the car might be driving into another car or hitting something, you can play it out yourself and say, well, for my students, I think this is going to be okay. They can cope with this. Or you might think, oh, my students may not be quite ready for talking about issues with crashes and so on. So you might sort of choose a scenario which is less scary for that. But in this one here, we're just using a parent with a pram crossing the road illegally while the don't walk sign's flashing. So because that's happened, the AI has avoided the person in front of them. But in doing so, in avoiding the pram and the parent, the car's driven into a cyclist. So let's have a look at what some of the options are here. So we're asking the question about responsibility. Who's responsible? So the owner of the car, even though they are the passenger, are they responsible? Is it the AI manufacturer, the people who built the AI? They've programmed it, or they've given it a set of rules. It might have said that avoid trying to make a situation where there's less harm to anything when you're getting an issue with hitting something or someone. The parent crossing the road illegally, causing the accident, are they the ones who are responsible, or is it the cyclist who should have avoided the car? And being a cyclist, if you choose D, I'll be very upset. So the poll, if you wanted to have a go, I'm going to say give my go. One of two. There we go. So again, you've got a few votes in there. Yep, someone's chosen the parent. I've chosen the car manufacturer just for something different. But again, you can have a discussion there about responsibility and how that plays out and what students think. Again, all these sort of ideas are, you could take the sort of idea that we've got is taking a scenario. You can make your own scenarios up so that you could talk about things that you think the students are in your class who they what they find more interesting, and you know, we've given you a bit of a run through with that. Next.
Yeah, these questions become really interesting with AI, and I think in one of the webinars, because we dedicate a whole webinar in primary and secondary just to the ethics stuff, and I think Carsten, you made a point in one of the webinars that the difference with a regular accident is that with AI, somebody has programmed the behavior. It's not it's not behavior that's being done on the spot. It's being programmed by someone, and that means the ethical questions are a lot more thorny in some ways.
Yeah, so
we wouldn't be prepared to purchase an AI that hadn't been trained for such edge cases, right? Just in terms of product safety.
Yeah, so it brings up a whole range of good discussion. So next slide. Just want to make this point about the life cycle of an AI and where there's a human in the loop at all stages, so that's really important. And in this analysis of AI applications, we look at this notion about we've got a life cycle of development. So when you're training the model, it's really important. You're testing it, then they're deploying it. So at each point, we're doing some safety checks, and we're making sure that there's a human who's basically controlling and monitoring the whole situation. So I think that's a really important point to raise, and we sort of bring that up in that lesson. So there's in those lessons we give you some really good structure. So if we're explaining the ethical issues, and a lot of kids need scaffolding to do that. So if we took a certain situation, and for example, if we looked at, I think there's one of the lessons looks at a skin cancer AI. So you basically got an app, and you use your camera and you look on your skin, and you basically say, oh, I don't know if this is a skin cancer, and you send that picture to your doctor. So that application, you can use that as a discussion point. Well, what could be some of the issues? Again, if the AI is not trained properly, what happens if it makes a mistake? What happens if it doesn't find something and there's no cost to access the lessons, Carolyn? No, it's all free. If the AI gets something wrong, again, that responsibility. In terms of the AI, the skin colors. So imagine all the different skin colors that would have to be reliable. So it would be really important to be testing. So again, we've scaffolded all these lessons. So it's really about just having a look through there what your focus is and what you're interested in terms of and what your students will be interested in terms of looking at the AI. So that's it for me for the ethical discussion, and I've finished with 2 minutes to spare.
Yeah, well, that's kind of a wrap up of what we were going to talk about. We've got a little bit of time to answer any more questions anyone might have, and I think I'd love to see one of your visualizations going too, Carsten. Carsten's provided a link there to his website. I've given the link there to the topic page on the Digital Technologies Hub, and I'll also put the link that takes you to the actual AI PL webinars, so professional learning webinars as well. I'll put that as well in the chat.
While you're doing that as well, I'll just mention those 4 videos that we've got. So the explainer videos on the actual DT Hub site, and what they're a really good intro with your students. Say, for example, when you're talking about machine learning, just to get that conversation going and talk about I think number 2 talks about how AI is applied in everyday life. So we use home automation as one of the examples, and we look at there's a really good one on sort of like a Netflix, like a video or film service that gives you recommendations. So all of that's really important to get your students to have a look at and to understand how these things are sort of in their everyday life that they might not know. We've also got in there recognizing AI. We've got a set of cards that you can download, and you could have a little basically with your students what's AI and what is their I'm just reading Carolyn's there. Is there a chance to come out to the school? Leave that with you, Nathan.
Yeah. Maybe if you email me, Carolyn, I'll put my email in. Maybe there's a way DLTV might be able to do something, or Carsten's in Queensland, but there might be a time in the year where he comes down, or myself, or maybe even Martin could come out. So yeah, I'll put my email in.
Yeah, it's a really fascinating area, and I had the privilege of working with 2 teachers from South Australia, and seeing the students, they were year 5 and 6 and year 3 and 4, they got so much out of this. It was amazing. And just that teachable machines, amazing. Just the tools, the one that Carsten showed you, the auto draw. If you just use those and just talk about AI and the questions about how does this AI understand what I'm drawing. But we mentioned before, Nathan, about the different sorts of resources that are around. So CSER had their course. It's an AI course. So again, it's sort of, you could have a dip in, dip out of that course for AI to learn about it. There's got a general course for digital technologies, but they have one specially for AI. There's also there's a CS Unplugged, the .org, the Oceans one, where they do a little course with students about machine learning. That's pretty cool. But all these resources are on the Digital Technologies Hub anyway. So if you go there, you'll find a whole lot of materials to start off with.
Awesome. Well, could I just say thank you to both of you for joining in with today. I mean, you know, we had such a good time producing these resources, and it's great that we can still share and tell people about them, because it's with everything with digital technologies teaching, there's so much stuff out there, but it's fine. It's having it curated and knowing what's useful as a teacher, I think, that's the challenge. So yeah, so thank you for those who've come along as well. And yeah, I'll turn the recording off now.